All right, so we're back here again talking about monomials. We'll call this monomials part 2. Yesterday we spent some time talking about different types of rules that we have in terms of monomials. Power to a power, where we take our exponents and multiply. If we're multiplying two variables, how we take our exponents and we add them together. What we want to get into today involves what happens when we divide our variables. So when we divide variables, if you think about it, multiplying our variables together, we said we're going to add those exponents. And so for multiplying means we add the exponents, and hopefully we can understand that dividing the variables means that we are going to subtract the exponents. Again, notice that the base, in this case a, stays the same. It's not changing. That kind of becomes pretty important when you start taking a look at some of the numbers that you may have. Like if I have 2 to the 4th divided by 2 to the 3rd, we don't want to take the 2's and actually divide them and call them 1. That would be bad because that's not how we're using our rule here. So our best bet is to recognize the fact that the bases are the same, the 2. We keep the 2, and now we subtract our exponents, and we just get an answer of 2 to the 1st or 2. Kind of take care of some stuff here. There we go. So when we divide common variables, we're going to subtract their exponents. Well, what happens when all of a sudden you're looking at a situation where you've got x to the 6th divided by x to the 6th? Well, if we apply our rule, that's x to the 6 minus 6, or x to the 0 power. So what exactly does that mean? Well, if we take a look at what we actually have here, we have x to the 6th, and we're dividing it by itself. And anytime you take something and divide it by itself, we know that that answer is always going to be 1. So if we can kind of make a connection here, x to the 0 power, we know that when we divide something by itself, it's 1. So here, x to the 0 power is actually going to equal 1, which takes us to another rule that we need to be aware of, which is anything to the 0 power is 1. Now, for the most part, that's true. There is a situation that we have to be aware of, and that involves negative numbers. If I have a negative number inside a set of parentheses and it's to the 0 power, that will equal 1. But if my negative number is not in parentheses and it's to the 0 power, that is not going to equal 1. It's actually going to equal negative 1. So something to be aware of. Parentheses around the negative number, you got 0 power, it's going to be 1. No parentheses, it's going to make that a negative 1. So just keep an eye out for that. Last thing that we really need to make sure we cover involves negative exponents. What happens if all of a sudden I have x to the negative 2nd power? How do I deal with that negative exponent? Is there something I should do to get the negative out of the exponent? So it takes us to this rule right here. Anything to a negative power is going to become its reciprocal, which we can kind of break down and take a look at in 2 separate ways. 1, if the negative exponent is in the numerator of a fraction, then we can move that variable into its denominator. So let's say we've got this x to the negative 2nd power here. I know I can't have a negative exponent. I've got to find a way for that negative exponent to become a positive exponent. What's the best way to go about it? Well, if I simply put that over 1, now actually applying the rule which says, hey, have that become its reciprocal becomes a lot easier. All right. It also makes it a lot easier to kind of put this little rule into play as well. So if I make it the reciprocal of x to the negative second over 1 would just be 1 over x to the negative second. But what happens is by changing and bringing this variable into the denominator, that changes our exponent from negative to positive. Well, what if we have a variable in our denominator that happens to be negative? Let's say we've got like a 2 over x to the negative third. Again, we don't want to have negative exponents. That brings us to the next part here. If we have a negative exponent in our denominator, then we want to take that entire variable with the power and move it into the numerator. So I'm going to take this x to the negative third. I'm going to bring it into my numerator. So my 2 stays put. My x comes up into the numerator. By doing that, my power becomes a positive. I can put it over 1. I can just leave it as it is and just call it 2x to the third power, and I'm all set. So those are the rules for 0 powers and negative exponents and when we divide. So let's take a look at a couple examples. All right. So today we'll start here with number 4. Here you can see we've got negative 4 times x to the negative second with a y and then z to the negative fifth. Basically what we want to do here is we want to get this to be all positive exponents. So again, an easy thing that we can do here is change this into a fraction. Simply put it over 1. And so by doing that, I got to start to apply those little rules for negative exponents. Variable, negative power. Variable, negative power. So what I'm going to do is take those variables and move them each into the denominator of that fraction. So let's think about this. X is moving down, the z is moving down. So my x to the negative second now becomes x squared. Z to the negative fifth now becomes z to the positive fifth power. So what's left over to be in my numerator? Well, I still have my negative 4, and I still have my y. And so that ends up being my final answer. All my exponents are positive, and that's a good thing. What about when we're multiplying and we've got negative exponents? Well, go back to your rules for multiplication from yesterday. You always want to add the exponents. So negative 2 plus 4, add on a negative 6, that gives us positive 2 minus 6, that gives us negative 4. Again, I would put that over 1. Now I know that I can move that x into my denominator, make it a positive 4 power. What about my numerator? What's going to be there? Well, again, like any other variable, if there's no number out in front, we can always put our 1 there. So when we move, that x to the bottom, our 1 is still on top. So 1 over x to the 4th power. And then lastly, let's take a look here at number 7. Bring that up a little bit. What happens when you have coefficients that won't divide evenly? Here we've got the 3 and the 2. Those won't divide evenly. Your best bet is to just sit there and make sure that they're reduced. Well, 3 over 2 is reduced about as much as it's going to be. So we can leave that alone and focus on the variables. So my 3 stays here, my 2 stays here, and now we focus on the variables. So using my rules for division, I know that I want to take and subtract my exponents. So m to the negative 3 power, or negative third power, minus negative 1. Minus negative, add a positive, that's m to the negative second power. N to the fourth divided by n to the negative fourth. So again, minus the negative power, add a positive, and so that's n to the eighth power. Again, variable, negative exponent, we're going to move it down. And so my final answer here would be 3 n to the eighth over 2 m squared. So that's our part 2 lesson on monomials and our rules for dividing along with zero exponents and negative exponents. And we'll see you when you get back to class. Have a great day.